The cosmic canvas, an introduction to the universe. Look up at the night sky, what do you see? Stars, planets, and endless darkness, but there's so much more out there. The universe is vast and mysterious. It's filled with wonders beyond our imagination. From tiny atoms to massive galaxies, the cosmos is a playground of discovery. Think about this. The universe is about 13.8 billion years old. That's older than our minds can truly grasp. In all that time, it's been expanding, growing, changing. The light from distant stars takes billions of years to reach us. When we look at them, we're seeing into the past. It's like a cosmic time machine. But what's out there in the darkness between the stars? That's where the real mysteries lie. Dark matter, dark energy, black holes. These are the puzzles that keep astronomers up at night. Dark matter, the invisible cosmic glue. Imagine a dance, galaxies twirling through space, but something's off. They're moving too fast. They should fly apart, but they don't. Why? Scientists think there's something we can't see holding them together. They call it dark matter. Dark matter is weird. We can't see it. We can't touch it. We can't detect it with any of our instruments. But we know it's there. How? By its effects on things we can see. It's like watching a mime. You can't see what they're leaning on, but you know something's there. Dark matter makes up about 27% of the universe. Normal matter, the stuff we can see and touch, that's only about 5%. It's like we're living at the tip of the cosmic iceberg. Dark energy, the force behind cosmic expansion. Now let's talk about something even stranger than dark matter, dark energy. In the 1990s, scientists made a shocking discovery. The universe isn't just expanding, it's expanding faster and faster. But why? What's pushing everything apart? Enter dark energy. Dark energy is like the opposite of gravity. Instead of pulling things together, it pushes them apart. And it's everywhere, in the space between galaxies, in the void between stars. Even in the room you're sitting in right now, it's invisible and mysterious. But its effects are enormous. Dark energy makes up about 68% of the universe. Most of the universe is something we don't understand at all. So what is dark energy? We have some ideas. It could be a property of space itself. The truth is, we don't know. Black holes, nature's cosmic vacuum cleaners. Now let's dive into something really mind-bending. Black holes. These are the bad boys of the cosmos. They're so dense that nothing, not even light, can escape their gravity. Imagine a star so heavy that it collapses in on itself. That's how most black holes form. Black holes come in different sizes. Some are as small as a city, others are millions of times more massive than our sun. And at the center of most galaxies, there's a supermassive black hole. Our own Milky Way has one. It's called Sagittarius A*. It's about 4 million times more massive than the sun. In 2019, scientists did something amazing. They took a picture of a black hole. Well, not the black hole itself, you can't see that, but they captured the glowing gas swirling around it. It was like seeing the unseeable. Section 5. Exoplanets, worlds beyond our solar system. Let's leave our cosmic neighborhood for a moment. There are other worlds out there, planets orbiting other stars. We call them exoplanets, and they're everywhere. As of 2024, we've discovered over 5,000 of them, and we're finding more all the time. Some of these planets are weird. There are hot Jupiter's gas giants orbiting close to their stars. There are super-Earth's rocky planets, bigger than ours, but smaller than Neptune. Some planets orbit two stars, like Tatooine in Star Wars. Others might be made entirely of diamond. But the ones we're most excited about are the ones that might support life. Planets in the Goldilocks zone, not too hot, not too cold, just right for liquid water. In 2023, scientists announced the discovery of several potentially habitable planets. One, called TOA 700e, is about 95% the size of Earth, and maybe, just maybe, we'll find signs of life. Imagine that. Section 6, the search for extraterrestrial life. Are we alone in the universe? It's a question that's haunted humanity for centuries, and now we're closer than ever to answering it. The search for extraterrestrial life is in full swing, and it's not just about little green men. We're looking for any sign of life, no matter how small. Where are we looking? Everywhere we can. Mars is a prime target. It once had water on its surface. Could it have harbored life? Europa, one of Jupiter's moons, has an ocean under its icy crust. Could something be swimming in those alien seas? And then there are those exoplanets we talked about earlier, but how do we look for life? One way is to search for biosignatures. These are chemical signs of life, like oxygen in a planet's atmosphere or methane, which can be produced by living things. We also listen. Radio telescopes scan the skies for artificial signals. Section 7. The birth and death of stars. Stars are the building blocks of the universe. They're cosmic factories forging the elements that make up everything, including us. That's right, you're made of star stuff, but how do stars form and what happens when they die? It starts with a cloud of gas and dust. Gravity pulls it together, it gets denser and hotter. Eventually it's hot enough for nuclear fusion to begin. Hydrogen atoms smash together, forming helium, and boom, a star is born. Our sun is a middle-aged star. It's been shining for about 4.6 billion years, but stars don't live forever. Small stars like our sun will swell into red giants. Then they'll shed their outer layers, leaving behind a white dwarf. Bigger stars have more dramatic ends. They explode as supernovas. These explosions seed the universe with heavy elements. Section 8. Cosmic mysteries, unsolved puzzles of the universe. The universe is full of mysteries. Some we've solved, many we haven't. Let's look at a few puzzles that still keep scientists up at night. These are the frontiers of cosmic exploration. The questions that drive us to look deeper into the void. First up, the matter-antimatter asymmetry. For every particle, there's an antiparticle. They should have been created in equal amounts after the Big Bang. But they weren't. If they had been, they would have annihilated each other, and we wouldn't be here. So why is there more matter than antimatter? Then there's the mystery of cosmic rays. These are high-energy particles that bombard Earth from space. Where do they come from? How do they get so energetic? We're not sure. And let's not forget about the Big Bang itself. Section 9. Recent breakthroughs in space exploration. Space exploration is moving at warp speed. Every year brings new discoveries, new technologies, new ways of looking at the cosmos. Let's check out some of the biggest breakthroughs from recent years. These are the stepping stones to our cosmic future. In 2022, NASA's DART mission successfully altered the orbit of an asteroid. It was the first time humans had changed the course of a celestial object. Why does this matter? It could be our best defense against asteroid impacts. The dinosaurs would have appreciated this technology. 2023 saw the launch of the Artemis program. Its goal, to return humans to the moon. And this time we're planning to stay. NASA wants to establish a permanent lunar base. It could be a stepping stone to Mars. Speaking of Mars, the Perseverance rover continues to make discoveries. It's found organic molecules that could be signs of ancient life. Section 10, the future of space discovery. What's next for space exploration? The future looks bright and weird and wonderful. We're on the cusp of a new space age, one that could take us further than we've ever gone before. Let's peek into the cosmic crystal ball and see what might be coming. First up, more missions to the outer solar system. NASA is planning a mission to Europa, Jupiter's icy moon. It might have an ocean under its surface. Could there be life there? We're going to find out. There's also talk of a mission to Titan, Saturn's largest moon. It has lakes of liquid methane. Weird, right? Closer to home, we're going back to the moon. But this time, we're not just planting flags, we're building bases. The Artemis program aims to establish a permanent human presence on the lunar surface. It could be a stepping stone to Mars. And speaking of Mars, human missions to the Red Planet are in the works. Section 11, reflections on our place in the cosmos. As we reach the end of our cosmic journey, let's take a moment to reflect, to ponder our place in this vast, mysterious universe. We are, as Carl Sagan said, star stuff contemplating the stars. Think about that. The iron in your blood, the calcium in your bones, it all came from exploding stars. We are tiny beings on a small planet orbiting an average star in an ordinary galaxy. And yet, we've peered into the depths of space and time. We've unraveled some of the universe's deepest secrets. We've sent probes to other worlds. We've even taken a picture of a black hole. Our curiosity, our drive to explore is truly remarkable, but there's still so much to learn, so many mysteries to solve. Dark matter, dark energy, the nature of black holes. These are just a few of the puzzles that await us. And who knows what else we might discover. The universe is full of surprises. Every answer seems to lead to more questions.